Welcome to Mastering Python Profile for Performance Tuning. Today, you'll learn how to effectively use Profile to identify and resolve performance bottlenecks in Python applications.
Welcome to this educational video on Mastering Python Profile for Performance Tuning. In today's session, we will explore Profile, a powerful built-in module in Python that allows developers to identify performance bottlenecks in their applications. Profiling is an essential skill for optimizing code efficiency and enhancing overall application performance. By the end of this tutorial, you will be well equipped to utilize Profile effectively, pinpoint slow code segments, and improve the performance of your Python programs. Let's dive in and start our journey to mastering performance tuning with Profile.
To effectively use Profile in your Python projects, you'll first need to ensure that Python is installed on your system. Since Profile is part of the Python standard library, there's no need for additional installations. Begin by opening your Python script and adding import CProfile at the top. This simple step allows you to integrate Profile seamlessly into your project. You can also run Profile directly from the command line by executing python mcprofile your script.py. This command will provide you with a detailed report of the performance metrics. Integrating Profile into your scripts is straightforward and can significantly aid in identifying performance bottlenecks. By setting up Profile in your projects, you're taking the first step towards optimizing your code and enhancing application performance. Once Profile is set up in your project, you can start collecting profiling data. Use the CProfile.run function to profile specific functions or entire scripts. This function provides a comprehensive overview of the performance metrics of your code. You can also store profiling data in a file for further analysis by using CProfile.run your function, output file. This allows you to review detailed function call statistics, including the number of calls, time spent per call, and cumulative time. By running Profile, you gather crucial data on your script's runtime performance. This data is instrumental in understanding how your code executes and where potential bottlenecks may exist. With this information, you can make informed decisions on optimizing your Python applications. Interpreting the output from Profile is a critical step in identifying performance bottlenecks. Start by reviewing the function call statistics provided in the report. Pay attention to functions with the highest call times, as these often indicate areas that need optimization. The report includes metrics such as the number of calls, total time spent, and cumulative time. Focusing on cumulative time can help you identify which functions contribute most to the overall runtime. Utilizing sort options like time, cumulative, and calls can provide better insights into performance issues. By pinpointing slow code segments, you can prioritize efforts to optimize those areas first. Interpreting Profile output effectively allows you to make data-driven decisions in enhancing your Python application's performance.
When working with large-scale Python projects, using Profile effectively becomes even more crucial. Profiling complex applications requires a strategic approach to manage large datasets and focus on critical performance areas. Start by identifying the most resource-intensive parts of your code. Profile allows you to efficiently profile these areas, providing detailed insights into their performance. By concentrating on the functions with the highest resource usage, you can optimize them for better efficiency. Additionally, Profile's ability to handle large datasets makes it an invaluable tool for large-scale projects. Applying Profile techniques to these projects can lead to significant performance improvements, ensuring your application runs smoothly even as it grows in complexity.
Visualizing profiling data can significantly enhance your understanding of performance bottlenecks. Integrating Profile with third-party visualization tools allows you to represent profiling data graphically, providing clarity and deeper insights. Tools like SnakeViz, PyCharm's built-in profiler, and KKakiGrind can be used to visualize profile data effectively. These tools help you identify patterns, trends, and correlations that may not be immediately apparent from raw data alone. Visualization enhances your ability to pinpoint bottlenecks and understand their impact on application performance. By incorporating visualization into your profiling process, you gain a more comprehensive view of your Python application's performance, enabling more informed optimization decisions.
While Profile is a powerful tool, there are common pitfalls to avoid when using it for profiling. One of the main challenges is profiling too much at once, which can lead to overwhelming amounts of data and make analysis difficult. Instead, focus on gathering meaningful data from critical sections of your code. Be aware of the profiling overhead, as Profile itself can introduce additional time to your application's execution. It's essential to interpret results carefully, understanding what the data represents and how it relates to your application's performance. Avoid the trap of premature optimization, where you spend time optimizing code that may not significantly impact overall performance. By navigating these common pitfalls, you can make the most out of Profile and enhance your Python applications effectively.
Maintaining performance improvements in your Python applications requires adherence to best practices. Regularly profiling your code helps you stay informed about any potential performance regressions. It's beneficial to incorporate profiling into your development workflow, making it a routine part of your coding process. After implementing changes, monitor performance to ensure optimizations have the desired effect. Documenting your performance improvements provides a reference for future development and helps track progress. Continuously optimizing for efficiency ensures your application remains performant as it evolves. By following these best practices, you can maintain the performance gains achieved through Profile and ensure your Python applications run smoothly. In conclusion, mastering Profile for performance tuning is an invaluable skill for any Python developer. We've explored the benefits of using Profile to identify performance bottlenecks and improve application efficiency. Profiling is a crucial step in optimizing code and ensuring your application performs at its best. I encourage you to practice profiling in your projects and explore advanced profiling techniques as you become more comfortable with the process. Apply the skills you've learned today to enhance the performance of your Python programs, and continue to refine your abilities in profiling and optimization. Thank you for joining us, and happy coding.